Hello, welcome to all of you. I am Balaji Murthy, physics faculty, teaching physics for all corporate examination and boards. My core strength is to build the concept of physics strong so that you can able to apply to solve the numerical problem of physics. Based on that, today we'll discuss one of the problems which is very fundamental and problem seems to be very little bit complicated. Here the problem says that the man of mass capital M is moving along the inclined plank of mass small m, which is inclined to the horizontal with angle theta. The question is asking you with what acceleration and in which direction the man should move. That means the man should move either in downward direction or upward direction so that the plank should not slip over this support. So if you look at the question and let us logically think of the solution. The forces acting on the plank due to the inclined plane and gravitation is here is mg sin theta. Even on man, it is mg sin theta. What coefficient of friction is given? There is a friction between plank and the man. We know very well that when you move ahead, while moving, if you move ahead, then the relative force is in the backward direction, and due to interlocking, the frictional force is in a forward direction, which will make you to get interlocked, and that's why you will be moving ahead. So the plank need not have to come down. Definitely, if the man will move in a downward direction, that means the frictional force on the man in the direction will, if it is moving downward direction, he will act force in the direction and frictional force will be in the direction. Okay. So frictional force on the man will be in the direction if it is moving in the downward direction. And on the opposite side, due to equal and opposite forces, the frictional force on the plank will be acting in the upward direction. This is one of the case. Otherwise, if the man will move up, what will happen? The man will move up. So frictional force on the man will be acting in upward direction, and due to equal and opposite forces, by Newton's third law, the frictional force on the plank will act in the downward direction, which will make the plank to go down, which we don't want it to go down. Therefore, definitely, to prevent the slipping of the plank, the frictional force on the plank should be in upward direction, so that the frictional force on the man should be in the downward direction. It says that the man will have to move in a downward direction, say with the acceleration a. Now, if you consider the man and the plank as a whole system, then the internal forces can be neglected, and the equation becomes now the total force acting on man and the plank system is given by downward direction mg sin theta plus mg sin theta. This is due to man and due to plank downward direction, which is equal to mass of the man and the acceleration of the man in downward direction to prevent the plank to not to move or slip downward. Because I wanted to figure the frictional force to prevent to nullify mg sin theta has to be in upward direction of the plank. Therefore, the acceleration of the man should be in downward direction. I will indicate by down arrow just to many. It does not mean that it is directed downward. It is along the downward direction of the plank. That is, if you take g sin theta common, that is m plus m divided by capital M into g sin theta, or the acceleration has to be in downward direction. I will indicate it downward, which is equal to 1 plus m upon m into g sin theta. So The answer to the question is the man should move downward direction with the acceleration is given by this equation, that is A equal to 1 plus small m upon capital M into g sine theta. That is the answer. The question is fundamentally a very good question. I am sure that you understand this question very clearly, and how we apply, we can even apply equation of motion differently for the man as well as Newton's laws of motion for on man and Newton's laws of motion on the planet separately solve it. That will increase the length of the solution. To nullify that or to minimize that, we apply the Newton's laws of motion, second law of motion, on the system of man and the plant together to simplify it in only one equation. That is the actually beauty of this question. I'm sure that you understood it very clearly and how to solve these questions in one step. So thank you very much to here to me, and sooner we will meet with the new conceptual question. See you soon. Take care. Thank you.